Hello everyone. In this video, we are going to discuss another question of fixed size sliding window. And the question is, we need to find out the first negative number in every window. Like हर window में पहला negative number बताना है. For example, let's say your array is something like this. -1, -2, 1, 3, -1, 2, -1, 0, -1, 4. Okay. So if this is, let's suppose the array, and let's suppose I give you the window size of 3. So what you need to do is, this is the first window, and which is the first negative number? The first negative number is -1. So you will just push back -1 in your answer. Okay, the next window of size 3 is this, and the first negative number in this is -2. Okay, so the next window of size 3 is this. The first negative number in this window is -1. Like 1 and 3 are not negative and -1 is negative. Okay, so next window of size 3 is this, and first negative number is -1. The next window of size 3 is this, and the first negative number is again -1. Then the window of size 3 is this, negative number is -1. Then the window of size 3 is this, negative number is -1 again. And the next window is this, and negative number is -1. Okay, so you need to return this vector. This is our required answer. So what we need to do? We need to return the first negative number in every window of size k. So how we can do this? See. सबसे पहले, first of all, if this question is asked to you, like given to you, now how you would identify that this is a question of sliding window? See, they have written and given that in every sub-array of size k, once you get this statement, sub-array of size k, like you are defining the size of some window, isn't it? So yeah, one of the approach in this type of question can always be a sliding window. Like I am not saying like it will only be it can only be solved by sliding window, or it will be definitely be solved by sliding window. But yeah, this can be one of the approach, and you should always give a try with this type of questions. Like you can try that approach if you find something in question like this, the sub array of size k. And how to identify whether this is a fixed size sliding window or a variable size sliding window? See, over here we are not defining some condition on we are not limiting the condition, we are limiting the window size, isn't it? We will like once you practice the size questions of variable size sliding window, you will get more idea about it. But for now, you can just keep in mind that if you limit the condition, then that is variable size sliding window. But once you limit the size of window, then that is fixed size sliding window. So over here, I told you to find the first negative number in the subarray of size k. So I have defined the size of subarray, and only in that subarray you need to look, isn't it? So yeah, I am validating the size of the window, I am limiting the size of the window, and hence this is a problem of a fixed size sliding window. Okay. So next is how we can solve this. The array is this. Okay. So yeah, let me take an. Okay. So okay, this is the array. Let's write down the array once again. -1, -2, 1, 3. -1, -2, 1, 3. -1, 2, -1. 0, -1, 4. Okay. So it may be the case like in case some k size window there is no negative number. So in that case you need to just print let's suppose 0. Okay. In that case you need to print 0. Now what you do, you will start from this number I equals to 0, and you will start in this number. Now just tell me, like we need to find out the first negative number, right? So can you think of some data structure which helps you like जो पहले आएगा उसको पहले लेना है? Like, is there any data structure like that? Like the first come, first serve. Isn't it? We are doing that only, na? First come, first serve. Is there any data structure which supports this kind of thing? Yeah, you guessed it right. It is queue. So what you can do is, you can maintain a queue. Let's suppose you have queue something like this. So if anyone is not aware of this data structure, you can just see like it is a simple syntax. Like queue is something which helps to take the element in the order which it comes. For example, if this is a queue, 1 comes, then 1 will first go over here, 2 comes, 2 will go over here, and so on. And let's suppose we want to delete elements. So first of all, 1 will be deleted and then 2 will be deleted and so on. And this will be the front element. Okay. So yeah, this is the data structure queue for us. So what we will do is, we will start like it is a fixed slice sliding window, isn't it? So first, what is our task? First of all, we need to complete the window size starting from 0. This is what we discussed in the last lecture, isn't it? So let's suppose window size is 3 in this case. So what you can do is, first of all, you will keep incrementing your j until you reach your uh, window size. So what can be the maximum value of j? The maximum value of j can be n minus 1. So we will keep a check of j less than n. Now what we will do? We will push the element in this queue only if it is a negative number. Okay, just see. We will push the element in the queue only if it is a negative number. So since the window size is 3, so yeah, if first of all, we will write the statement that if nums of j is less than 0, then what we will do, you will push that number inside your queue. Okay. Secondly, you will check that if you have completed your window size or not. So if j minus I plus 1 is the window size, so if it is less than k, so what was the template? We will simply increase the value of j and continue. Because first of all, we need to complete the window size, isn't it? Okay. If this is not the case, so if the window size is greater than k, so since it is a fixed size sliding window, so you always know that when the window size will be greater than k, we only need to move I one steps forward, isn't it? Like if you let's suppose you have window size of 3 and you have completed this 3. Now when you move to the other element and exceed the window size will become 4. So at this point of time, you only need to shift your starting element only by 1 point, isn't it? So yeah, I discussed this in the last lecture. Like for the fixed size sliding window, you always need to shift your starting element only by 1 point. So what you will do is, so if it is greater than k, you will simply check that if the starting element, that is the element present at nums of I, if it is less than 0, then we know that we have pushed this inside the queue. So yeah, we need to delete it. So we will just write q dot pop, and after this, we will just increment our I. That is the contribution of I. First of all, what we did, we removed the contribution of I if it has contributed, and then we simply incremented our I. Now after that, what we will do, we will maintain an answer vector, and in our answer vector, we can push back our answer, like the answer dot pushback q dot front. Okay. So yeah, this is the approach we are going to follow. Let's one dry run for this array, and you will get the idea booklet. Okay, so let's write out the array once again. -1, -2, 1, 3. -1, 2, -1, 0, -1, 4. Okay. So this is our queue initially. Let's write it out. First of all, our I is here and our j is here. So first of all, we come to this jth element. It is -1. Okay, so we push that in our queue. Then we come to -2. Okay, it is a negative element. We push this in our queue. Again, we come to 1. And this is not a negative element. We will not push it in our queue. And next, what we will do, we will check that if the window size is less than k, but no, we will just cross that condition. The window size is not less than k. So we will check if window size is greater than k. No, it is also not the case. So we will just push back. Like if this is our answer vector, we will push back q dot front element in our answer. Okay, we pushed it back. Now when your j comes over here, and you check like if it is a negative number, no, it is not a negative number, you will not push it. Then you will check if the size of window is less than k. Is it? No, it is not the case. So now you will check that if the size of window is greater than k, and you get, yeah, it's greater than k. So what you will do is you will shift your I one step forward. But before doing that, first of all, you need to check that if I contributed anything. In this case, I contributed -1, isn't it? Because nums of I is less than 0. So what you will do, you will remove the first element from your queue, that is, you will pop, and you will simply increment your I. Now your I comes over here. After this step, your window size will be equals to k. So now you will push your front element of the queue in your answer vector. Okay. Now your j comes over here. Once your j comes over here, you check the window size. It exceeds k. So you will check that if I contributed to the answer. So yeah, I contributed to the answer because nums of I is less than 0, isn't it? So what you will do, you will delete the first element of Q. Like when you came to J, you pushed -1, isn't it? So now you will delete the first element of Q. And yeah, after deletion, you will shift your I. And now you know that your window size is K. So you can push -1 in your answer. Okay. Now your J shifts over here. Now once your J shifts over here, you check that if 2 is a negative element. No. So we will not add that in our Q. Okay. Now we know that window size exceeds the value of K. And then we need to shift the value of I. But over here, nums of I is greater than 0 or greater than equals to 0. What this means? This means that this I has not contributed to your answer. So you will simply shift your I and not do anything. Okay. Now you know that your window size is K. So you will just push the front element in your answer vector. And so on you will do until you reaches your J over here. So yeah, this is the approach we are going to follow. And every time when your window size is K, let's suppose your window size is K. So you need to keep a check that if Q is empty. If Q is empty, this means there is no negative element in this window, isn't it? So in that case, we need to push only 0. In that case, you need to push 0. And if it is not the case, like Q is not empty, so just push the front element of Q because that is the first negative element in that window. Isn't it? So what we are doing, like ये approach कहाँ से आया हमें कि हमें क्यों ही use करना है? Because we were told to like we need to push back the first negative element, isn't it? So अगर हम लोग left से right आ रहे हैं, so how can we keep the check like which is the first negative number? By just inserting them in the queue because queue is first come first serve. First negative number का क्या मतलब है? That came first in the window, isn't it? So if that came first in that window, so yeah, that is also like first in the queue. So yeah, top element of queue से वो चीज हो जा रहा है. So let's code it down once and you will get the idea. Let's take the size of the array in n. Let's take the inputs in array. Okay. So now let's take the window size from the user. Once we are done with it, let's initialize our starting point and the value of j, and let's maintain a queue. If anyone is not familiar with the syntax of queue, you do not need to worry. Just focus in this. This is the approach of sliding window. So just try to gather the information. Queue, we define the queue. Now we will travel till we reach the end. And if our present element of j, like if our present element of j is less than 0, so we will push that element in our queue. And once we are done with it, we will check if the window size is less than k. If that is the case, so we will simply increment our j and continue because we can't do anything now since our window size is less than k. If this is not so, we will check that if we exceeded the window size. And if we exceeded the window size, what we can do is we can just remove the contribution of ith element if it contributed. So we will check if ARR of I was less than 0, means it contributed to our queue, and we can just pop that element from our queue. Because if it has contributed, it was the topmost element of the queue, isn't it? So popping will just remove that element, and after that we can just increment our I. Once we are done with it, we can maintain an answer vector, and we can keep a check like if the queue is empty. If the queue is empty, this means there is no negative element in this window, and so we can just push back 0 in our answer. Otherwise, what we can do? Otherwise, we can push back the topmost element of our queue. Like it is given as q dot front. Okay. So once we are done with it, we know that answer vector contains the required answer. So what we can do is we can just print that. Okay. So yeah, let's take the input to the same as we discussed in our example. The array size is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the array size is 10 and the array values are -1, -2, 1, 3. Okay. And it's -1, 2, -1, 0. And the next element is -1 and 4. Okay. And what is the window size we took? Window size we took was 3. So let's run it and see the answer. Okay, we have not got our answer actually. Let's see what error we have done. Okay, we missed J++ over here. We missed J++, isn't it? Like you need to increase your size of window every time you traverse, isn't it? So yeah, this is the answer vector and it is same as we got when we try run it. Okay. So yeah, I hope you understood this question. Like this is the approach we follow in sliding window. In sliding window, हमें तो विंडो पर अगर विंडो साइज फिक्स्ड है देन हमें बस निकालना है कि वो कंडीशन हम लोग कैसे सेटिस्फाई कर सकते हैं, हाउ वी कैन सेटिस्फाई दैट कंडीशन. इफ वी आर एबल टू डू दैट then yeah, your job is done. Just code it down and yeah, it's simple. Meet you in the next video for that. Thank you.